Hello, Algebra. This is Mrs. Cryer again. We are on page 19, day 7, solving quadratic and linear systems algebraically. So, algebraically means not using the graph. So, we're going to be solving, this is going to feel very similar to Unit 10, which was the unit right before this one. I'm going to start with the first problem, but as I'm doing the first problem, I'm going to refer to the procedure at the top. Okay, so you'll notice in number 1, we have a quadratic right here and a line right here. Make sure both equations are in y equals form. Check. They both are. Y equals y equals. Substitute the linear equation in the y of the quadratic equation. Here's what this means. Let me change colors real quick. I'm going to take this line, this part, and plug it in for that y. So basically, in my next step, I'm not going to see any more y's. 2x plus 2 equals x squared minus x plus 2. What we're doing there is substitution, but you can think of it as just like get rid of the y's and set them equal to each other. Okay, get a new quadratic equation into standard form. So we want to be 0 equals, because we want to get it equal to 0 for solving, ax squared plus bx plus c. Okay, the 0 equals can be on either side. I like when the x squared is positive, and since the x squared is positive right here, I'm going to keep it on that side. So I'm going to subtract 2x and I'm going to subtract 2. And get them lined up with their like terms. So I've got a 0 on this side. X squared stays x squared. This is going to be minus 3x. And positive 2 and negative 2 go away. So I'm solving this. Solve the quadratic equation using one of the 3 methods. The 3 methods are quadratic formula, completing the square, or factoring. Factoring is what I'm going to use here because as soon as I see they both have an x in them, I know I can do a GCF. Now, you can go off to the side and write a box if you want. To me, I could just see that they both have an x in it, so I'm taking an x out and thinking about what's left. This would be an x, this would be a minus 3. Once it's in factored form and equal to 0, I can do my t-chart. And I set this equal to 0. And I set x minus 3 equal to 0. Add 3, and I get x equals 3. Now, at this point, a lot of people are going to walk away from this problem, and they're going to think they're done. But let's talk about what we're actually doing. We're trying to figure out where the parabola and the line intersect. And these guys are not just x values. Like, yeah, it intersects at 0, x equals 0, and x equals 3. Those guys are xy points. So my answers should be xy points. Okay? Now, most of the problems that we have, if not every single problem that we have in algebra, is probably going to be a parabola with a line intersecting it at 2 places. So we should be expecting 2 answers. Okay, the line does not always have to hit the parabola twice, but for the purposes of algebra, you should be looking for 2 answers when you're solving algebraically. It could also, just as a side note, I can erase this after I draw it. You could have a line that never intersects the parabola. You could have a line, this is a very specific thing, and I'm not that great at drawing it. You could have a line that hits it only once. But for all the cases that we have today in this packet, we're looking at something like this. So, what have I found so far? Well, what I found so far is the x values of those points. So as soon as I have these, I am now going to start my answer. It's not done. These are the x values. You can see I'm setting up a point. Okay? How am I going to get the y values? Well, you plug in. Now, what would I rather plug into, the line or the parabola? I'd rather plug into the line. 10 times out of 10, I'd rather plug into the line. Y equals 2x plus 2. So I'll start by plugging in 0. When I plug in 0 for x, I get y equals 2. So in that point, it's 0, 2. There's one of my answers, an intersection point. Now I'm going to plug in 3. I get 8. There is my other intersection point. So step 5 is a big step just because people will think they did a lot of work once they get x equals 0, x equals 3. That's kind of what our answers looked like in Unit 10, so people think they're done. You're not done. You got to find the whole point. Check your solutions. Here's where I would go to the calculator. Now I'm going to go, since I'm not going to pull up the calculator on this. I don't know how to do that. I'm not that fancy yet. But if I take 0 in the calculator and I plug that into this parabola right here, I should definitely get 2. When I take 3 and plug it into my calculator, I should get 8. Okay, there's other ways to check. You could put both of these in y equals. I'm pointing. Both of these can go into y equals. Look at the table. Okay, make sure they both have the point 0, 2 and 3, 8. Those are ways to check. Okay, on to the next stage. Okay, I'm on number 2. I don't have the words right in front of me, but I'm just going to recap them out loud. Make sure both equations are in y equals form. Now, last time we were lucky that they were, so that was nice. This time, not difficult. I'm just going to subtract the x from both sides of the line, and I'm looking at y equals negative x plus 1 after I get it equal to y. I'm going to zoom in a little bit here. Now that they are both equal to y, I will set them equal to each other. This is me taking this and plugging it in for y here. AKA, once they're both equal to y, just get rid of the y's and set them equal to each other. So I'm looking at negative x plus 1 equals negative x squared plus 4x minus 3. I do not like that the x squared is negative. So this is going to make it a little bit trickier. I mean, you can solve it with a negative x squared. I'm never going to. I'm always going to make that x squared positive. So I'm going to add the x squared over to this side. I'm going to subtract the 4x from both sides. And I'm going to add the 3. Notice I'm just taking the opposite sign. And then on this side, boom, 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 that's going to give me my 0. I got everything lined up. So I've got x squared minus 5x plus 4. And there's my quadratic that I have to solve. Okay, so it's a trinomial. This is not going to be a GCF. I am still going to solve it by factoring. If you wanted to use quadratic formula, you could. We need the two numbers to multiply to be a positive 4 and add to be a negative 5. It can be tricky when we're working with positives and negatives, but I know that both of these would have to end up being negative. So my two numbers are negative 4 and negative 1. And just to double check, negative 4 times negative 1 is a positive 4. Negative 4 plus negative 1 is a negative 5. So that's looking good. So we're going to break up that middle term. Instead of a negative 5x, I'm going to have a negative 4x minus a 1x. Those are the two numbers I just found. This gets broken up. From there, your teacher may have solved this a little bit differently. Let's not get caught up in that. I'm just going to use a backwards box, putting the first two on the first story of that box, putting the next two on the next story, and then just saying like, okay, what is the GCF of that top row? And again, when it's just an x squared in that first spot, those are my favorite ones because they're the easiest. Double check that last one. Negative 4 times negative 1 is a positive 4. We're looking good. I've got my two factors, x minus 1 times x minus 4. T-chart. I'm going to skip the setting equal to 0 part and the showing that part just to save a little bit of time. Here's where we're not going to walk away. We are finding points. Our final answers are points, not just x values. There are 2 places where that parabola runs into the other, runs into the line. I'm going to go back to, let me grab a highlighter real quick. Right here, this guy, that's what I'm going back to, the original. And I'm looking at x plus y equals 1. I'm going to take one of my x values. The first x value I found was 1. 1 plus y equals 1. Subtract 1. Whoops, I'm solving for y. I got a 0. So 0 goes right there. Yay, there's one of my points. X plus y equals 1. My other x value was 4. Subtract 4. I'm looking at y equals -3. Yay, there's my other point. Okay, so just to be clear, this is what we found. We found this parabola up here. It's an upside down parabola. And this line right here run into each other at 2 different places. What are those 2 places? 1, 0, and 4, -3. Okay, last one. Now, this one's got a little trick in it. Oh, time out. You would check using your calculator, okay? You would check using your calculator. You can put these 2 things that I have highlighted. Well, I guess, hang on. This into y1, this into y2. Check your table. Make sure they both include the 2 points that you found. That's a good way to check. Okay, on to the last one. I have to solve for y. Here's where I would anticipate mistakes happening. You have to solve this second one for y. I'm going to subtract x. There's more than one way to do it, and this would be wrong. Hope you're listening. Hope you don't have this on mute because you're going to think this is right, and this is not right. This is wrong. What did I forget? I forgot the negative. That negative is still there, so we have another step before this is actually solved for y. I'm going to divide by -1. And every single term needs to be divided by that -1. And that's going to really just change the sign on everything. Now I have it set equal to y. So now that this is equal to y and this is equal to y, I can get rid of the y's and I can set them equal to each other. So I've got x squared minus 7x plus 13. X squared minus 7x plus 13 equals, and x minus 2 was what I just found when I solved that for y. Okay, here we go, getting equal to 0. I'm looking at x squared minus 8x plus 15 equals 0. We're factoring. I'm going to speed it up a little bit here. 15, -8. I need 2 negatives, -5, -3. Those 2 negatives give me a positive 15 when multiplied. And they give me a -8 when I add them. I'm putting the first 2 in the top story. Nice easy x squared there, making those guys easy. Negative times a negative gives me a positive. I'm looking at x minus 5, x minus 3. Yeah, that's in factored form, and when I solve it, I'm going to get x equals 5 and x equals 3. And if I walk away here, I'm going to miss at least half of the points on the problem because our answers are points. You're like, why does she keep saying that? We get it. Well, as an algebra teacher, we know. We know what happens. Kids think they're done here, they walk away. You're finding points. We got a parabola, a line. We want to see where they intersect. They don't intersect at something like x equals plain old 5. They intersect at 5, comma, y value. 3, comma, y value. So you're going to take those and plug them back in. Again, I would use the line. There's just more room for error if you're going to plug into the parabola. There's just a lot of places that you know it could go wrong. And for the x value of 5, I'm getting 3 for the y value. And I'm just going to skip ahead to the answer for the last one if you want to pause it real quick and then come back. When I plugged that in, I got 1, and there's my 2 answers. Okay, there's a lot there. Hopefully a lot of that seems like review, the solving part. If you weren't great at it, well, now's your chance to get more practice. All right, I hope everybody's doing well and staying safe and healthy.